This is tutorial question number 2. A cylinder shown in figure Q1 is made of uniform material with diameter 0.45 meters. What is its specific weight? Will the cylinder be stable in the position shown? So we have a material like this one. So this is a solid specific material. So it is a diameter, so means that the shape is in cylindrical shape. So and then this shape is floating in kerosene. So the specific gravity of kerosene is 0.82 and the submerged area is 0.6 meter. The total length of this one is 0.75 meters. So again, to simplify this calculation, we start with drawing the free body diagram like this one. So for sure, because the weight has the object has weight, so for sure it has center of gravity. So we draw the center of gravity here, and it is the center point or the middle point in the object, because in this question it no statement about the location of the gravity. So if the height is 0.75, so we could say that the center of gravity is 0.75 divided by 2. So and then we draw the center of buoyancy, because we know that when one object floating in water or in liquid, so they have force of buoyancy. So force of buoyancy needs to act on center of buoyancy, and center of buoyancy will act at the center point or at the center point of the submerged area. So because the submerged area is 0.6 meter, so we could assume that the location of B is, the distance here is 0.3 meter from the origin. So this is the origin. So first, we calculate the force equilibrium. So we know that force of buoyancy is equal to weight. So and then we could calculate force of buoyancy using rho A volume. It is equal to the weight. So weight here is rho G and also volume. But you must remember that to calculate the force of buoyancy, we need to use the rho for liquid, the rho for kerosene here, the rho G and volume, and this volume is the volume of displaced liquid, and this rho is the rho for the object, for the material, and the volume here is the total volume of the material. Okay, so please understand the equation to calculate force of buoyancy and weight. And then we could simplify the equation for force of buoyancy here by Sg times rho G and A and H. So A here is the cross-sectional area of the cylinder. So and then the weight is rho G, A and H. So we have rho G, the gamma here is the specific weight. Okay, so please revise your understanding of this one, because we learned about specific weight, specific gravity in our first chapter. So and then from this calculation we could get it is equal 6.44 kilonewton per meter cube. So this is the specific weight of the object. So and then we need to calculate the stability of the cylinder. So again, the equation is start here. So the Gm is equal Bm minus Bg. So and then we could determine the value of Bg here by using this equation, Og minus Ob. So Og is quite simple, because we know that the overall dimension of the object, so it is 0.75 over 2. And OB here is also easy to calculate, because the submerged depth is given in the question, so which is the 0.6. So and then OB will become 0.6 over 2. So we could get it is equal to 75 times 10 to the power of 3 meters. So and then we could calculate the BM here. So BM here is I moment divided by volume. And then you must be very careful because in this question, okay, we have submerged here. So the water is until this level. What you need to do is you need to imagine from the top view what is the area or what is the shape on the free surface here. So here the shape is circular, circle. So we use the equation for moment of circular here, which is pi d to the power of 4 over 64. So you have a pi d to the power of 4 over 64. So I think you could check this equation in textbooks later on. Okay, so for example, if we have one condition like this one, for example, we have a rectangular shape here. So and then we have a circular shape at the bottom. So if the water is in this level, so the water surface only at this location, so you need to use the idea of circular here because the free surface submerged only at the circular area. And then if the water rise, okay, for example, and then it floating until this level, so means that now at the free surface here the shape is rectangular, so the I moment should base on the rectangular area. So this idea you need to understand this one because you need to determine the equation of moment of moment there by using by looking the area on the free surface of water. So if you calculate the value of BM here, so it is equal 21.1 times 10 to the power of minus 3. So and then we could calculate the value of GM by this equation BM minus BG. So it is give us a negative value. So means that this location or this orientation is unstable. So the answer is the cylinder is not stable in the position shown above.